back to my channel. So today we are going to talk about the limit definition of the derivative. Okay, so using the limit definition of the derivative, find the derivative of f of x equal to square root of x. Okay, so let's solve this problem. So the limit definition of the derivative says f prime of x will be equal to limit as h approaches 0, f of x plus h minus f of x over h. Okay, all right, as you can see, in order to find the derivative of this specific function, we need these three terms, right? However, f of x is already given to us. F of x is already given to us, square root of x. It's given. We need to find out f of x plus h, right? F of x plus h. All right, so how can I find f of x plus h? The best way to solve this problem is using placeholder. Okay, so instead of writing x, I'm just going to draw a parentheses like this. Okay, so use a placeholder like this. Okay, so the idea is I'm going to substitute all the x with x plus h. Okay, so I'm going to replace x with x plus h, x plus h. Okay, so now since we cannot simplify this anymore, we're going to leave it as it is. Okay, all right, so now we have f of x and we have f of x plus h. What we can do, we can plug it in and simplify, and then we are done. All right, let's do that. All right, so let me write the definition one more time. So f prime of x equal to limit as h approaches 0, f of x plus h minus f of x divided by h, limit as h approaches 0. Well, what's the value of f of x plus h? We already found out the value of x plus h, which is equal to square root of x plus h, right? Minus f of x, it's given to us, square root of x over h. Now we have a problem, right? The whole idea is some way, somehow, we want to get rid of this h, right? We want to get rid of this h. How can we get rid of this h? So let me tell you a trick. Whenever you see radical sign like this and you have a negative or positive sign, one thing you can do, you can multiply the numerator and denominator by the conjugate. Okay, by the conjugate. All right, so what does conjugate mean? So if you have a plus b, the conjugate will be a minus b. All right, so if you have a minus b, the conjugate will be a plus b. So basically that means you change the sign. Okay, all right, let me show you what do I mean by that. So limit h goes to 0, so x plus h minus square root of x over h. So what I'm going to do, I'm going to multiply the top and bottom by the conjugate. Okay, so what's the conjugate of this? Square root of x plus h. So the only thing that you do, you change the sign. So if you have a negative sign, you make it positive. Square root of x, close bracket. Whatever you do on top, you should do the same thing in your denominator, x plus h plus square root of x. We can do that because they cancel each other out. Okay, now let's take a look what happens here. All right, So limit h approaches 0. So now when I see my numerator, it kind of reminds me of the difference of perfect square formula, okay? I think I have made a bunch of videos on factoring using differences of perfect square. You can check that out. So it kind of reminds me of differences of perfect square formula, okay? So it kind of looks like a minus b times a plus b, okay, which is equal to a square minus b square, okay? So this is our differences of perfect square formula. So we're going to apply the same technique, okay? Let me erase this. So we are going to apply the same technique. So the answer is going to be a square, which is x plus h whole square minus b square. In this case, our b is square root of x squared. I hope at this point you understand why did we multiply top and bottom by the conjugate. We want to multiply top and bottom by the conjugate so that we can get rid of the radical sign, okay? All right, so we have h square root of x plus h plus square root of x. All right. Now let's try to simplify a little bit more. Limit h approaches 0. And don't forget to write limit, because we haven't done anything with limit. You should write limit as h approaches 0. So as we know, the radical sign and the square, they cancel each other out. So we have x plus h minus x over h square root of x plus h plus square root of x. Can we simplify this a little bit more? Yes, the x values cancel each other out. All right. Now, if you're taking calculus, I strongly suggest that you do the problem step by step. It's going to help you. You won't make any silly mistake, okay? H square root of x plus h plus square root of x. All right. So now the question is, can we simplify? Yes, we have h on top and h on the bottom, so we can cancel them out, okay? So again, all the calculation that we just did, we did it because we wanted to get rid of this h, okay? So that is the goal. So limit as h approaches 0, I have 1 square root of x plus h plus square root of x, okay? We're almost there. Now the question is, can I plug it in? Can I replace h with 0? The answer is yes. Now we can, okay? So that's going to give us square root of x plus 0 plus square root of x. That's going to be 1 over square root of x plus square root of x. Since we have like terms, we can add them up, right? So think of it this way. If you have x plus x, what do you get? 2x, right? So if I have square root of x plus square root of x, I should get 2 square root of x, okay? And that's it. We found out our derivative using the limit definition of the derivative. The last thing that you can do, if you want, you can actually double check your answer using the derivative rules that you already know, okay? So let's double check. So if I have square root of x, well, square root of x can be written as x raised to the power half. Wonderful. If we apply the derivative rule, the power comes in the front and we have to subtract 1 from half, right? So that's going to give us 1 over 2 x raised to the power negative half. Well, 1 over 2. So if you have a negative power, you can write this as 1 over x raised to the power 1 half. Well, raised to the power 1 half basically means 2 square root of x. So as you can see, our answer is correct. Again, if you have any question, any concern, let me know. Take care.